Hello and welcome to this video in which we will talk about fighter jet technologies. What makes one fighter jet better than another? So we will analyze what are the characteristics of the planes currently available on the market, which are therefore 4.5 and 5th generation. First, we need to go back to the origins of the planes that we define as being of the 4th generation, which corresponds to several criteria that were available from the mid-70s. In the Western Bloc, to first replace the Mirage F1, the American F4 and F5, then the Soviet side's MiG-21. First we have what we call the glass cockpit, that is to say we replace the dials that we had in all the planes. Here we are in an F4 and we put screens with electronics and the ability to configure missions. And as time goes by, the cockpit will modernize until the arrival of what we call the head-up display, that is to say the head-up display, which is the high head sight that we find today on all planes. Here we are in a Mirage 2000, and this miniaturization allows then to have increasingly efficient developments until having indications that are directly available in the pilot's helmet. This is what we call helmet sights, and it allows to designate a target with a simple look. And today this technology is systematically available even on less prestigious devices like the Indian Tejas or the Sino-Pakistani JF-17. It is necessary in this area. It is also necessary to underline the delay that was observed on the Soviet side to integrate these technologies that are linked to microelectronics. For example, the screens of the Sukhoi and MiG used cathode array screens for 2 more decades than their Western counterparts, which made it impossible to integrate these systems and HUDs or helmet sights. In fact, the Sukhoi 30 and Sukhoi 35 integrated Western components, including helmet sights, until 2014. The head-up display of the Sukhoi 30, for example, was supplied by Thales, and with the Russian invasion of Crimea and the annexation of Crimea, we stopped supplying them with these equipments, so much so that Russia had to develop them locally, but when it seeks to export these materials, it still offers the equipment, the Sukhoi 35 with North Atlantic Treaty Organization equipment, which are considered superior to those offered by Russia. For example, it was in the context of a tender with Indonesia. The second swimmer innovation that corresponds to 4th generation aircraft is the electric flight controls that we first found on the Mirage 4, then on the American F-15 and F-16. The F-14, the first 4th generation fighter, lacks electric flight controls but remains highly maneuverable. So this technology, it allows for planes that are going to be much more maneuverable, much more unstable as well. However, instability is not like in airliners where it's considered a problem. Here we simply have the ability to have a maneuverability that is going to be much more significant because it's going to be managed by a computer, and this gives a big advantage in dogfighting, and it has allowed to push the concept to planes like the Sukhoi 47 Berkut with its reverse sweep. It's an experimental plane from the late 90s, but in reality it corresponds more accurately to the needs, since at that time we have missiles that can carry very far and therefore have planes that fight by doing swirling combat. Pilots still train for it, but it seems very unlikely that it would still be useful today. So what's the point of making a plane that's only good in swirling combat? And on the other hand, it loses capacity in other areas. That's why this concept has not been pushed beyond the prototype. However, one element is absolutely fundamental for the 4th generation. It's what we call the fight beyond the horizon, the beyond visual range, the beyond visual range. And this is allowed in particular by new sensors, but also by the availability of long-range RR missiles, like for example the Air Intercept Missile 54, which equipped the F-14 from the early 70s, and which allows to engage targets that are sometimes beyond 150 kilometers, especially thanks to the very good radar of the F-14. Its effectiveness has been widely observed, particularly in the Iranian Air Force against Soviet Iraqi aircraft, as it managed to shoot down 2 MiG-23s, 2 MiG-25s and 3 Tupolev 22S that were shot down by this pair with the F-14. And it stopped when France provided Iraq with Mirage F1S that were equipped with electronic countermeasures and Matra missiles from the end of the 80s, and at that time it was Iran that lost 4 F-14s, but even today Iran officially has operational F-14s. After the Air Intercept Missile 54, the US will introduce the Air Intercept Missile 120, also known as the Advanced Medium-Range Air-to-Air Missile, in the early 1990s. The Advanced Medium-Range Air-to-Air Missile will have different categories and generations that continue to improve to the present day. And in this area, one must realize the lead that existed on the Western side, since the Russians only integrated a missile equivalent to the Advanced Medium-Range Air-to-Air Missile in 2015 with the R-77 missile. And today, it's the Meteor from MBDA that has what we call the no escape zone, that is to say, the area, the envelope in which a plane has no chance of getting out. And so, it is the highest in the world with a distance of more than 90 kilometers, which obviously benefits the planes that are equipped, starting with the Eurofighter, the Rafale and the Gripen. And today there are works to integrate this missile on the F-35 and on the KF-21 Korean, which is still in development today. In terms of armaments, so we have seen the very long-range RR missiles, but there is also a new category of air-to-ground weapons, which, with the advent, what we call precision munitions, that is to say they have a high efficiency since they can hit a target to within a meter, which means that we can also reduce the amount of explosives and therefore potentially reduce what we call collateral damage. In other words, we will kill fewer civilians who are next to military targets, or else we have this target that will be directly designated by another plane or another member of our coalition, and that is what is allowed by the transmission with what we call the most known tactical data links is the link 11, the link 16, the link 22, and in this field also we must imagine the delay that the Soviets had taken, since even today the tactical link called the TKS-2M, which equips the fighters, since the Sukhoi 27 only allows to have 20 connected terminals. Concretely, if you have a Russian airborne warning and control system called the Beryeva 50 that detects a target, it cannot designate it for the benefit of an S-300 air defense system that would be on the ground. So, the Russians are currently developing a tactical data link called OSNOD, especially for the Sukhoi 57, but these specifications are ultimately those that we have in the L-16, which has been used since the 70s for all countries that are more or less to Western standards. And another criterion of the fourth generation, generation and a half, which is linked to this data transmission, is also everything that is around the fusion of sensors, which was the first generation, but it is then the fusion of data. That is to say, it allows the centralized exploitation of all the plane's sensors on a single panel, so it greatly simplifies tasks for the pilot, since the plane will be able to make a correlation. The computer makes the connection between all the different sensors. That is to say, the information that can come from the radar, the Otronic system, electronic warfare equipment, infrared homing devices that can even come from missiles, but also elements that come from the tactical data link, which allows to remain discrete while being able to exploit the radar of an airborne warning and control system, which is more powerful and which remains out of reach of enemy weapons. And it allows everyone to have the same tactical situation, all members of a force. And if this is the culmination today, when an F-35 pilot presses the button to take down a target, it's not necessarily his missile that will go off. It could be a missile that is on a boat, on another plane that is in another place, and so it includes the system as a total whole. The other advantage to data fusion is that it allows for a 360-degree situation tracking for planes. For example, all sensors are connected, and the F-35 uses for this its radar associated with its 5 electro-optical equipments, which are located all around the plane. So we have in the field of data fusion planes that are excellent, that are very, very reputed, like for example the Rafale and the F-35. And in this field also, the Russians are very clearly lagging behind, and this was revealed when the Sukhoi 35 participated in the competition in South Korea, where clearly South Korea said that data fusion was almost non-existent on the Sukhoi 35. It's only sensor fusion if we move to radar. So you have understood that a radar has several modes, that is to say that it is not the same radar for aerial targets to do terrain tracking, to fire a missile at a boat, for example, and that's why from the 60s we have a new generation of semiconductors that allow to develop radars that we call electronic scanning radars. That is to say that instead of having a radar which is composed of a single large transmitter that needs to be oriented towards its target and which scans, we have a radar that allows to orient the wave in multiple small beams that will focus towards one or several chosen axes. From then on, it is possible to track multiple devices evolving in opposite trajectories, even when exceeding the radar's theoretical opening. The first plane equipped was the Russian MiG-30. From the 90s, this technology evolves again, but rather than having a single large transmitter that is distributed by all the small systems, all the small peaks that we see at the front, now radars are composed of 1,000 to 1,500 transmitters receivers, each being totally independent to aim in a different area, but also to choose the frequency on which it will emit, which offers a lot of advantages. And this is what we call active antenna electronic scanning radars. And this is what we call active electronically scanned array, and it really marks a turning point compared to the passive antenna electronic scanning radar that we call PESA. And so the first plane that was equipped with an active electronically scanned array, it was the Japanese F2, which was an evolution of the F-16, and it has a lot of advantages. First, obviously, there is a better resistance to jamming. Since each small transmitter receiver can emit on a different frequency, it's very complicated to be able to totally jam everything on this radar, whereas in the past, when we have with a PESA, the whole radar emits on a single frequency since there is really only one transmitter at the origin. So all it takes is to send the same frequency back to the radar and it will be completely jammed, while with the European Space Agency, as there are dozens of different frequencies, you will not be able to jam the entire signal. And so these are radars that are much more resilient to electronic warfare then, as each subsection of the radar can aim in a different direction, it can be assigned a different task. So the radar, by having only one, it can ensure both terrain tracking, jamming, RR mode, air-ground mode, etc. Then there is a range that will be increased by up to 50% compared to PESA radars. And the last element is obviously that maintenance is greatly facilitated since we have a great redundancy in the transmitters, which allows it to function despite a few transmitters failing. And this is where we really see a distinction between Generation 4 aircraft and what we call Generation 4.5 aircraft. And all aircraft are equipped today with active electronically scanned array radars, except the Sukhoi 35, which is still equipped with PESA, while an aircraft like, for example, the Eurofighter always has PESA in Europe, but the new Eurofighters that are delivered are with active electronically scanned array radars, and the old ones are being updated. If we stay on the sensors, we also need to address a very important dimension of optics and optronics. That is to say that after infrared cameras like forward-looking infrared, which were there from the beginning, we also now have artificial intelligence that now allows to lock onto a target, to follow it automatically despite its movements, or even directly engage weaponry on a moving target. And this is what we call infrared search and track, which stands for infrared search and track. This allows to designate a target for the benefit of a guided bomb or a missile in a totally passive way without radar emission, which would reveal the presence of the plane. Except that this system, it costs so much that it is very difficult to implement. For example, on the F-15EX, which is equipped with an infrared countermeasures, it costs more than $10 million per copy. So it is nevertheless found on all recent aircraft, the Eurofighter, the Rafale, the F-35, even the Sukhoi 27 and its descendant, the Sukhoi 35. But on the other hand, it is not on the F-22, even though it was originally planned. So remember for what reasons. The American F-22 at the beginning, it was a plane that was very advanced, so it was supposed to have the infrared search and track, except that in the 90s, there is the collapse of the Soviet bloc. The United States considers at that time that there are no more enemies, so they drastically reduced the budget and the orders in weapons, and instead of buying 648 FF-22, as it was originally planned, they will only buy 187, and in addition, they reduced their unit cost by notably cancelling the buy-place version, but also by removing certain equipment like the infrared search and track to such an extent that today it is so lacking that they are setting up an upgrade program to allow to reintegrate an infrared search and track from optical sensors, notably laser detectors. There is the collapse of the Soviet bloc. The United States considers at that time that there are no more enemies, so they drastically reduce the budget and the orders in weapons, and instead of buying 648 F-22, as it was originally planned, they will only buy 187, and in addition they reduce their unit cost by notably cancelling the buy-place version, but also by removing certain equipment like the infrared search and track, to such an extent that today it is so lacking that they are setting up an upgrade program to allow to reintegrate an infrared search and track from optical sensors, notably laser detectors. And I refer you to a press review in which we talked about this future version of the updated F-22. So you see, we have 5th generation fighters on which equipment that has become classic on all generation 4.5 planes is missing. And that's why the border is very blurry, in fact. And in reality, the 5th generation was defined precisely at the release of the F-22, and the goal of the Americans was to make an impression, to show the areas in which the United States was very ahead of their adversaries, notably the Union of Soviet Socialist Republics at the time. And so the planes that we consider to be of 5th generation, they must obviously possess everything that is expected of a generation 4.5 plane. That is the tactical data link, an active electronically scanned array radar, data fusion, but also have a multi-mission capability which requires a high onboard computing power, but also hyper-maneuverability. So it's a requirement that is often linked to vector thrust, also being able to fly at very high altitude, also being able to fly in supercruise. That is to say, supercruise is when you can exceed Mach 1, so the sound barrier without needing to use what we call afterburner, which is a mode in which we re-inject fuel into the engine, which allows to accelerate even more, but on the other hand, it makes a big blowtorch in the salt, so it's easy to detect, it makes a lot of noise, and like that it consumes a lot of fuel, it greatly reduces its operational range. And the last parameter is stealth. Instead of having simple discretion, fifth generation planes want to be totally stealthy. So you see this border is really blurry. Since a plane like the Rafale, you know how much I love it, a plane of officially generation 4.5, it's the most versatile plane that exists in the world today, and it has all the characteristics of a fifth generation plane except its stealth, while the F-35 or the Sukhoi 57 do not have supercruise, even though officially they are fifth generation, and the F-22 does not have the infrared search and track, even though it too is of fifth generation. So on the contrary, we see also planes that are declared of fifth generation, like the J-20 or the Sukhoi 57, which are clearly not stealthy, and on this point it's really important to put it simply. The discretion of each plane, it is expressed with what we call the equivalent radar surface. So the larger the equivalent radar surface is, the more capable we are of detecting them from afar, and a plane that has an equivalent radar surface that is 10 times larger, that is to say that we will be able to detect it with a radar twice as far away. So according to American data, an F-15EX, whose equivalent radar surface is about 4 square meters, will be detected at 320 kilometers by a Russian S-400 air defense system. So the F-35, which is stealth, could get closer to less than 40 kilometers without risk, which allows to deliver guided bombs on the target, the Rafale, at the F-4 standard, because I remind you that between the F-4, between the F-3R, between the current Rafales and the F-4, there will be an improvement of its discretion, since it is discreet and it is not stealth. It could get closer to the S-4 radar up to 100 kilometers without risking being detected, because its equivalent radar surface would only be 0.1 square meter, and so it is within range to shoot, for example, cruise missiles that could hit the target, or have the future missiles that would go back up to the source of a radar. We are talking, for example, about the GM-88, which is massively used in Ukraine by the Ukrainians. By comparison, the Rafale will have an equivalent radar surface that will be 0.1 square meter, and while the Chinese J-20 would have an equivalent radar surface that would be between 1 and 3 square meters. That is to say that it's barely better than what we have with an F-15EX, while it is officially a fifth generation aircraft qualified as stealth by China. And what you see on the screen are the analyses that have been conducted by enthusiasts who have modeled the aircraft, and from that, Carey will define what will be its equivalent radar surface. So according to, once again, these studies, the theoretical equivalent radar surface of the Sukhoi 57, it is about that of the Rafale, if and only if the Sukhoi 57 solves its stealth problems that it had on the first copies, because we saw its screws, which were apparent. We saw very clearly that in terms of industrialization, everything was not totally clear, and it is for this reason that the Indians abandoned the Sukhoi 57 project in 2018, explaining in particular that Russian industrialization was not at a sufficient level to really make it a stealth aircraft, or even sufficiently discreet. India was supposed to buy 144 Sukhoi aircraft, but tested the Rafale in the mid-2010s, allowing a comparison between the Rafale and the Sukhoi. 57 India found the Sukhoi 57 to be poorly designed with subpar avionics, unsuitable radar, and high purchase and maintenance costs. Russian engines have a lifespan 3 times shorter than those on the Rafale or most American engines, even on fifth generation aircraft. Or recognized as being of fifth generation, we can ask questions about their real quality and their real superiority over fourth generation aircraft. That's also why most manufacturers refuse this classification, which is imposed by the United States and has a very clear commercial value. So you see it's really on stealth that American aircraft make the difference in the ranking here. You see the table that we made in the Air and Cosmos magazine. You see the F-15, the Sukhoi 35, the J-20. They have a radar equivalent surface that is superior to 1. The Rafale, the Eurofighter, the theoretical Sukhoi 57 and the F-18 have a radar equivalent surface that will be less than 1, and we only have the F-35 and the F-22 that really stand out in terms of stealth. And so, if we look at the current aircraft programs that are still in development for this fourth and fifth generation, we obviously have the Russian Sukhoi 75, which is a derivative of the Sukhoi 57. Its expected flight date was supposed to be 2024, but it was already very credible before the war, and the program will certainly probably be cancelled for lack of outlets for several reasons. Firstly, the war in Ukraine has proven the difficulties of Russian aviation. I refer you to the videos in which we saw that there was Aero Club navigation equipment in the Sukhoi 34 and in the Sukhoi 30. Then, there is a serious shortage of components, not to mention the diplomatic breakdowns with prospects like Turkey and the Emirates, but also all the equipment that has been recovered, which will greatly benefit the Allies, since once again, the two Sukhoi 35, the dozens of Sukhoi 34 and Sukhoi 30 that have been shot down, they will be recovered, they will be analyzed, as well as all the electronic war bodies we found in the woods, and all this means that the ability of Western planes to destroy or be superior to Russian weapons, it will be further strengthened in the coming decades, and so there will be very, very little chance that they will be able to sell even their Sukhoi 75. There is another program that is relatively well known, which is called the KF-21 that is made in South Korea, which positions itself as being the equivalent of the Rafale, that is to say fully multi-mission halfway between generation 4.5 and 5, except that it will not have super maneuverability. On the other hand, it should eventually have a weapons bay to further improve its discretion, and it should be deliverable from 2026. India, for its part, is developing a plane called the AMCA, of which we don't know much, except that officially they say it is of fifth generation and it should be available in 2029, but given the Indian difficulties to develop the Tejas, it is hard to imagine that they could so quickly make a fifth generation plane. And finally, we have Turkey, which has been developing the TFX for 20 years, which is a fifth generation plane, which was supposed to be operational in 2023, but today nothing has been done yet. It still doesn't have an engine, its architecture has not been finalized yet. So the goal of having a plane by 2030 seems objectively very ambitious, so we think rather around 2035 if the TFX manages to reach its end. So you see, this question of Generation 4S5 is very porous. It's a bit variable geometry depending on what the marketers from the United States had managed to define at a certain time. And the real revolution is really going to come with the sixth generation planes, since they will include directed energy weapons, laser communication, artificial intelligence, combat cloud,